So, good morning, students. I think we have done till harmonic progressions, AMGM concept, and also telescopic series, I guess, right? So, today we'll observe few things. I'll solve few questions for you. So, understand them properly. 1 square plus 4 square plus 7 square, and so on, if I consider, right? So, in order to solve this type of problems, I already gave few formula. Let us recall them for a sec. I'll put it over here. Sum of natural numbers where I is starting from 1 to n is given to be as n of n plus 1 by 2. And sum of squares of natural numbers where I is starting from 1 to n, which actually refers to 1 square plus 2 square plus 3 square plus so on, is actually given to be as n of n plus 1 into 2n plus 1 by 6. And what about sum of cubes of natural number where I is starting from 1 to n? It will be n of n plus 1 by 2 whole square, which also can be written as summation I, where I is starting from 1 to n whole square. Right, beta? So these are the very important formulae we are going to take. Okay. So here there is sum of odd squares basically. So the difference is there basically if you observe, right, sir? So 1, 4, 7 and so on. If you observe, this is actually in AP, right? It is actually in AP. So what is the first term over here? 1. And common difference, how to find the common difference? 4 minus 1, which is equals to 7 minus 4, which is exactly equal to 3. And D come up as 3, right? So A we have and D also we have. So yeah, this is the first term and the common difference we had. Now we know that sum of n terms is actually nothing but term 1 plus term 2 plus term 3 so on. We can write it as summation Ti, where I is starting from 1 to n, and we don't know how many terms are there, so we are taking it as nth term, right beta? Now observe it. First we have to find what is TR. TR is nothing but a general term. Okay. Here we need to find the general term first. How to find the general term of an AP? TR is equals to A plus R minus 1 into D, which is nothing but 1 plus R minus 1 into 3, which is 1 plus 3R minus 3, which goes like 3R minus 2. So therefore TR is equals to 3R minus 2. And as I already said, Sn is equals to summation TR, where R is starting from 1 to n. Now put it over here, summation 3R minus 2, where R is starting from 1 to n. Now we are having two terms over here, split it accordingly. Summation R is equals to 1 to n, 3R minus summation R is equals to 1 to n, 2. As we already know, if any constant is there, we are going to take it out of the box. So 3 times summation R starts from 1 to n times R minus 2 times summation R is equals to 1 to n, 1. Now here 1 is adding n times, so 1 plus 1 plus 1 plus 1 so on. How many times it will be? N times, so it will be n. And this is actually nothing but sum of natural numbers. So it will be 3 times of n of n plus 1 by 2. Okay. So 3n square plus 3n minus 4n upon 2, which goes like 3n square minus n by 2. N of 3n minus 1 by 2 is the summation. Okay, beta? So this is how we have to solve the special series. And we'll solve few more questions also. Okay, we'll solve few more questions. Let me take the next question on it. The question is 1 plus 1 plus 5 plus 12 plus 22 so on. So how to solve this question? Okay, 1 plus 5 plus 12 plus 22. This is one of the major concept of sequence and series, sum by difference. Okay, using the difference you are going to find the arithmetic progression. Using the difference only you are going to sum it. So here, if you observe the difference between two terms, so this topic is called as sum by difference. That is nothing but if you observe the difference between two terms, 5 minus 1 is actually 4 and 12 minus 5 is actually 7, right beta? And next 22 minus 12 will be actually 10. Understood the process? So it will be, the difference is 4 here and the difference is 7 and the difference is 10 and so on. The first difference is actually in AP. The difference is actually in AP. This type of questions how to solve in the sense, consider it to be as Sn. Okay, consider it to be as Sn. Let Sn is equals to 1 plus 5 plus 12 plus 22 and so on. The same Sn, put it a little forward by taking it as 1 plus 5 plus 12 plus so on up to what it will be, Nana? An, and this will be An minus 1 plus An. Okay. Now subtract the terms. It will be 0 is equals to 1 plus 4 plus 7 plus 10 plus so on up to An minus this one, right? Minus An minus 1. Okay, minus An. Now what is nth term? Take this to the front side. So it will be An is equals to 1 plus 4 plus 7 plus 10 plus so on up to An minus 1. Okay. Now we know that common difference is 3 and the first term is actually what it will be, beta? This is the sequence. First term will be 4. Now similarly 1 plus and this will be n minus 1 by 2 times of sum of n terms. Okay, this is having how many terms? This will be having n minus 1 terms. Okay, n minus 1 terms. So it will be 1 plus 1 is the additional one, n minus 1 by 2 times of, okay, n minus 1 by 2 times of 2 okay, sorry, 4 plus n minus 1 into 3. This is used by Sn formula. Sn is equals to n by 2 times of 2a plus n minus 1 into d form. Okay, therefore it will be something like 1 plus n minus 1 by 2 times of 8 minus 6, it will be 2 plus 3n. Okay beta, this is the nth term of the given sequence. This is how you have to find it. And one more, there is a shortcut actually. There is a shortcut how to approach it in the sense, if the first difference is in AP, then nth term is taken to be as an square plus bn plus c. You can take it as Tm is equals to an square plus bn plus c. If you observe, this is actually gives you quadratic equation. Understood? No? This is actually giving you quadratic equations, but the constants are differing. Whatever the a, b part is there, that is actually differing, but it is still in quadratic equation. Understood? So similarly, if the difference, I mean like take it as first difference, okay, if second difference is in AP, second difference is in AP, then nth term will be cubic. Here it is quadratic and here it is cubic, where Tn is equals to an cube plus bn square plus cn plus d. Okay beta, this is how it is actually varies. So let us look into one problem and we'll verify it how it actually process. Let's take a question. The question is 8, 14, 22, 32, 44 and so on. Okay, this is actually the sequence, how it actually varies. Okay, so the difference of 8 and 14 is actually 6, and 14 and 22 is 8, 22, 32, 10, 32, 44, 12. The difference is actually in AP. Here first difference is in AP. If the first difference is in AP, what is the scenario beta? That nth term is quadratic, an square plus bn plus c. Sir, now there will be one confusion, sir. What n value we have to take? What is the Tn value we have to take? Right? Simply, we have how many variables are there? 3 variables are there. A, B, C are real numbers. We need to find them first of all, right? So that means we need at least 3 equations to find A, B and C. 3 variables, we need at least 3 equations. Simply, what is the term 1? Term 1 is 8, which is nothing but A plus B plus C. First equation. And term 2 is 14, which is equals to A into 2 times 2 square is actually 4A plus 2B plus C. This is going to be a second equation. Okay. Term 3, which is how much it is? 22. 22, which is 9A plus 3B plus C. This is third equation. Alright. So these are the 3 equations you have. Now try to solve them. Solve 1 and 2. Solve 1 and 2. We'll get it as 4A plus 2B plus C is equals to 8. For A plus B plus C is equals to, oh, this is 14 and this is 8. Subtract it. We'll get it as what beta? C gets cancelled and 3A plus B is equals to 6. And by solving second and third equations, it will be 9A plus 3B plus C, 4A plus 2B plus C is equal to 22 and this is equal to 14. Subtract it, it will be 5A plus B is equals to 8. Okay beta, 5A plus, yeah. So now solve these 2 equations. Take it as 4th equation and 5th equation. Okay, solve 4 and 5. It will be 5A plus B is equals to 8, 3A plus B is equals to 6. Subtract the both. 2A is equals to 2, A is equals to 1. Substitute A is equals to 1 in any given equation. 5 plus B is equals to 8, B is equals to 3. Okay. Similarly, put A is equals to 1, B is equals to 3 in any of the above equations. It will be A plus B plus C is equals to 8. So it will be 1 plus 3 plus C is equals to 8. C is equals to how much beta? 4. Now therefore Tn is equals to an square plus bn plus c, right? That means Tn is equals to n square plus 3n plus 4. This is the nth term. This is the nth term. Sir, we have to verify it also, right? Put n is equals to 1. Put n is equals to 1. Verification. If you want to verify, it will be put n is equals to 1. It will be 1 plus 3 plus 4, 8. What is first term? What is first term, beta? 8. Satisfied? And we will go for the second term. Put n is equals to 2. Now what it will be? 4 plus 3 plus, 4 plus 6 plus 4. It's actually 14. Second term is also satisfied. So similarly you can also verify all the things. Next part, for sum. For sum, how to find the sum, beta? Sn is equals to summation Tn, Tr, where r is starting from 1 to n, right? So therefore summation n square plus 3n plus 4. Okay, beta. Now it will be summation n square plus some 3 times of summation n plus 4 times of summation 1. So it will be n of n plus 1, 2n plus 1 by 6 plus 3 times of n of n plus 1 by 2 plus 4 times of n. Now if you want to solve, you can solve it, or else you can do the rest. This is the sum of n terms of the given 8 plus 14 plus 22 so on series. Clear, beta? Okay, now this is how you have to solve the questions later. Let us consider one more question, not on this basis, it's a different sector. Let a1 comma a2 comma, let me decrease the font actually, a1 comma a2 comma a3 so on be in AP such that summation k starts from 1 to 12, a 2k minus 1 is equals to minus 72 by 5 times of a1, where a1 is not equal to 0. If summation k starts from 1 to n, ak is equals to 0, then n is equals to dash. N is equals to dash. How much it will be? Observe the property first of all. They gave a1 is not equal to 0. Let us consider a1 to be a. Okay, a1 to be a simply. Now we need common difference also, because it is in AP. Let us consider common difference is in D. Common difference is actually D. Okay. Now according to this property, this statement, this condition they gave, summation k starts from 1 to 12, a 2k minus 1 is equals to minus 72 by 5 a1. Okay, beta. This is the thing they gave. Now observe it. 2k minus 1 in the sense it will be simply put k is equals to 1, it will become a1. When put k is equals to 2, it will be 4 minus 1 a3 plus a5 plus a7 so on up to 24 a23 it will be. Okay, beta. Up to a23 it will be is equals to minus 72 by 5 a1. Okay. Now sum of these terms, basically, right now sum of these terms will be what? Simply if you take it out of the box, it will be so it will be a1 a3 plus a5 a7 so on up to a23 is equals to minus 72 by 5 a1, right, beta? So it is simply a plus 2d plus a plus 4d plus a plus 6d so on up to a plus 22d, right? These are the terms actually. Is equals to minus 72 by 5 a. Now How many a's are there, beta? 12 a's are there. So 12a and plus how many d's are there here? 2, 4, 6, 8 up to 22. How much it will be? 2, 4, 6, 8 so on up to 22. It is simply how much now? So you can solve it, or else you can, if you want to directly, you can write it also 2, 4, 6 so on up to 22. So it will be, how many terms it will be there? 11 terms will be there. N is equals to 11. N is equals to 11 upon 2 times of 2 plus 22, which is actually 11 by 2 times of 24. Okay. So 11 by 2 into 24d is equals to minus 72 by 5a. So you can directly take out 12 common. 12 times of, it will be a plus 11 by 2 into 12d is equals to minus 72 by 5 into a. Okay. Therefore it will be 6 times, and this will be this one. So 5a, 10a it will be. Okay. Now this will be 12a. 12a plus 132d is equals to minus 72 by 5a. If you solve it accordingly, so it will be 12a plus 72 by 5a plus 132d is equals to 0. 60a plus 72a plus 132 into 5, 10, 15, 16, 5, 6, 60, d is equals to 0. 72, 60, 2, 32, 132, a plus 660, d is equals to 5. So we already know 132 5s is actually 660. If I take 132 common, a plus 5d is equals to, sorry, this is 0, equals 0. So a is equals to minus 5d. This is the a value we had, and we need to find n value, right? So it will be simply put it over there. N by 2 times of 2a plus n minus 1 into d is actually equal to how much, beta? 0. Okay, is it 0? So minus 10d plus n minus 1d, in the sense nd minus d is equals to 0. So it will be how much? Minus 11d is equals to nd, no, 11d is equals to nd. So n is equals to 11 is the answer. Okay, beta. This is how you have to solve the questions. And this is actually previous year questions of, this one is previous year question of JEE Mains 2023. Okay, this is JEE Mains question of 2023. Similarly, we'll do one more question on it. Let a1, a2, a3 so on be a GP of increasing positive numbers. If a3 into a5 is equals to 729 and a2 plus a4 is equals to 111 by 4, then 24 times of a1 plus a2 plus a3 is equal to how much? They are asking this. So listen up. Let us consider, let the first term of GP, let us take it as BA. Okay, and common ratio will take it as R. Let us consider this one. Okay, and they gave a3 into a5 is equals to 729. So a3 is actually known to be as AR square and a5 is actually AR power 4. Put it over here. AR square into AR power 4 is equals to 729, which is A square R power 6, which is nothing but AR square whole, okay, AR cube whole square is equals to 729, right now. So 729 square root is nothing but 27. So that means AR cube is equals to 27. From here we got it. Okay. Now they are asking you to find what beta? Okay, they gave one more property which is nothing but A2 plus A4. Right, A2 plus A4 is equals to 111 by 4, which is nothing but AR plus AR cube is equals to 111 by 4. So AR cube is equals to how much? 27 is equals to 111 by 4. So therefore AR is equals to 111 by 4 minus 27, which is equal to AR is equals to 27 into 4, it will be 28, 108. So it will be 111 minus 108, 3 by 4. AR is equals to how much? 3 by 4. Now we have first equation and this is second equation. If I divide it, okay, AR cube by AR, it is nothing but 27 by 3 by 4 by 1. So 27 by 1 into 4 by 3, and this will be 9s. So AA gets cancelled, R square it will be R square. R is equals to 3 into 2, which is nothing but 6. Okay, R value is equals to 6. And similarly, therefore, A into 6 is equals to how much beta? 3 by 4. 1s, 2s, A is equals to how much? 1 by 8. This is the A value and this is R value. Now they are asking you to find what property? Which one? 24 times of A plus AR plus AR square. 24 times of A plus A2, A2 plus A3. Yeah, A1 plus A2 plus A3 is equals to how much? Which is nothing but 24 times of A plus AR square. 24 times of A value is how much? 1 by 8. AR value is 3 by 4. AR square will be 1 by 8 into 36. So 24 times of, so this will become 1 by 3, 8 3 is 24, so it will be 3 plus 8 4 6 24, 6 into 3 plus 3 into 36, which is nothing but 3 plus 18 plus 18, 108, 18, 16, 26, and this will be 3, 129 is the answer. 129 is the answer. This is how you have to solve a question. This is also a previous year question of which session? This is 2024 only. Okay, take one more question on it. Okay, the number of terms of an AP, is even, then sum of all odd terms is 24. The sum of all even terms is 30, and the last term exceeds the first by 21 by 2. The number of terms which are integers in the AP is how much? So they are asking you to find number of terms which are actually integers. Okay, which are actually integers. This is how they are asking. So what is the solution? What is the properties we are going to use? Observe here. They gave first property, they gave it as number of terms in the AP is 2n. Okay. Sum of all terms will be equal to, odd terms is 24, sum of even terms is 30. Last term exceeds the first by 21 by 2. Then this one they are asking. Okay, clear. Now observe it, Nana. A2 plus A4 plus A6 plus so on up to AN is equals to how much? 30. Okay, where n is even. N is even. Remember this. And A1 plus A3 plus A5 plus so on up to AN minus 1 is equals to 24. Okay, now this is how they gave you the question. And we know that, let us consider this is first equation, this is second equation. AN minus 1 will be what, Nana? D, right? This is how we know. This is the thing we know, right? Now if I take first equation minus second equation, what it will be? A2 minus A1 plus A4 minus A3 plus A6 minus A5 plus so on up to AN minus 1 is equals to 6. This is D. How many D's are there? How many D's are there? Total n D's are there? No, n, not n D's. So the n is odd number, sorry, even number in the sense is actually n by 2 times of it. N by 2 D is equals to 6. Okay, so nd is equals to how much? 12 it is. Nd is equals to how much? 12. So now observe it properly. They gave one more condition. Last term is actually exceeding first term by how much? 21 by 2. Yeah, 21 by 2. So an minus a1 is equals to 21 by 2. an is equals to what, beta? A1 plus n minus 1 into d is equals to, sorry, minus a1 is equals to 21 by 2. A1 gets cancelled. nd minus d is equals to 21 by 2. Sir, what is nd? 12. 12 minus d is equals to 21 by 2. So therefore d is equals to 12 minus 21 by 2. 24 minus 21 by 2, which is 3 by 2. D value is how much? 3 by 2. So here is the D value. Now we have first term we have, we don't have the first term yet. So we have number of terms and we have the common difference. Now what we have to do, Nana? What we have to find? A also we have to find. Sum of odd terms is how much? Sum of odd terms. Sum of odd terms is 24, which is nothing but odd is how much? If n is equals to 8, in the sense odd terms will be 4 by 2 times of, what is the first term in the odd terms? So 2a plus n minus 1, n is equals to 4 minus 1 into d is 3 by 2, or d is how much? 3 by 2, right? Just a second. So d is equals to 3 by 2. Oh, okay. So sum of odd terms is equals to 24, and n value is how much, beta? N into 3 by 2 is equals to 6. So 2's n is equals to 4. So here 4 by 2 times of 2a plus, but here we are taking odd terms, beta. Okay, 4 by 2 in the sense you are actually multiplying and dividing with 2. Okay, so 2a plus 4 minus 1 into 3 is equals to 24. So it will be 2's and this will be 12's. 2a plus 12 minus 3, 9 is equals to 12. 2a is equals to 3. A is equals to 3 by 2. A is equal to how much? 3 by 2. Okay. Now they are asking you to find how many terms are there. Okay. integer terms are there. So now what is the AP nana? AP is equals to how much? First term is 3 by 2 and second term is common difference is 3 by 2 plus 3 by 2, it will be 3. Okay, so 3 by 2 plus 2 times of 3 by 2, it will be 9 by 2 and again 6, 15 by 2, 9, 21 by 2 and 12 and so on. Therefore number of terms is 8 and integer part will be, integer values is equals to, integers will be how much? 4. Okay now, oh, nd is equals to 12, right? Nd is equals to 12, so it will be 8. Yeah, odd terms will be 4. This is how the question is. Okay, yeah. Let us look into one more question. This is one more new pattern. If 1 by 1 power 4 plus 1 upon 2 power 4 plus 1 upon 3 power 4 so on up to infinity is equals to pi power 4 by 90. Okay, pi power 4 by 90 and 1 upon 1 by 4, sorry, 1 upon 1 power 4 plus 1 upon 3 power 4 plus 1 upon 5 power 4 so on up to infinity is actually alpha. Okay, 1 upon 2 power 4 plus 1 upon 4 power 4 plus 1 upon 6 power 4 so on up to infinity is how much? Beta. Okay, now these are the two cases if I consider. Now they are asking you then alpha upon beta is equals to how much? This is the question they are giving. Both are actually till infinity, so all the things are up to infinity only. Okay, this is one of the important problem. This model is like repeatedly asking, keep on. So observe the scene here. 1 upon 1 power 4 plus 1 upon 2 power 4 plus 1 upon 3 power 4 so on up to is infinity is pi power 4 by 90. Okay, and similarly beta is equals to 1 upon 2 power 4 plus 1 upon 4 power 4 plus 1 upon 6 power 4 so on up to infinity. So if you observe, this is actually even numbers, even number in the sense 2n. Yes or no? Can I take just 2 power 4 common out of all the box? It will become 1 power 4 plus 1 upon 2 power, sorry, how much? 2 power 4 plus 1 upon 3 power 4 plus so on up to infinity. Can I? What is this value? Pi power 4 by, this will be 16 pi power 4 by 90. Any doubts? This is actually beta value. Sir, what is alpha value now? Alpha is equals to 1 upon 1 power 4 plus 1 upon 3 power 4 plus 1 upon 5 power 4 and so on up to infinity. We don't have even terms over here, we only have odd terms. Can I just add 2 power 4 plus 1 upon 4 power 4 plus 1 upon 6 power 4 so on up to infinity minus 1 upon 2 power 4 plus 1 upon 4 power 4 plus 1 upon 6 power 4 so on up to infinity. This will become 1 upon 1 power 4 plus 1 upon 2 power 4 plus 1 upon 3 power 4 plus 1 upon 4 power 4 so on up to infinity minus 1 upon 2 power 4 plus 1 upon 4 power 4 plus 1 upon 6 power 4 so on up to infinity. Right, this is nothing but pi power 4 by 90 minus, and this will be beta, which is 1 by 16 into pi power 4 by 90. Okay, 16 minus 1 by 90 into pi power 4. Okay, beta, this one only 16 pi power 4. Okay, 16 pi power 4 minus pi power 4 by 90 into 16, which is equal to 15 pi power 4 by 16 into 90. This is what alpha is. So therefore alpha upon beta will be what? 15 times pi power 4 upon 16 into 90 divided by pi power 4 upon 16 into 90. 90, 90, 16, 16, pi power 4, pi power 4. So the answer is 15. Okay, this is how you have to solve the rest of the questions. Okay, now so I'll give you one more question again. I'll give few questions as homework. Try to solve them and come back tomorrow. In an AP, if S40 is equals to 1030 and S12 is equals to 57, then S30 is equals to S30 minus S10 is equals to how much? Okay, this is one question. If you want, I'll give you options also. 525, 510, 515 and 505. Okay, this is one question. And next question is here. If the first term of an AP is 3, sum of first four terms is equal to 1/5 of the sum of next four terms. Then sum of first 20 terms is equals to how much? First 20 terms is equal to how much? These are the questions you have to solve. These are the two questions. You can solve them and give them on tomorrow. Okay, sure. Bye. Have a good day.